The radio tower was always fake.
I don't know where that tower is from. That tower might be from like Malaysia or something. There for a while. Whenever I travel, I would take pictures of radio towers. Okay, you can recording. All right, so I just need to share my screen here, right? So, and okay, here we go. And you're seeing this, and all right, actually, so yeah, it's great to see you all, and appreciate your patience. This semester, I know everyone's sick of online in some respects, right? It does have its advantages, so but yeah, I'll be here probably for the next couple of weeks. Haven't decided exactly when I'm heading back home, but probably before Easter. So I think we have a Friday off during that Easter break. So but talk real quick about yeah, might do this over again, but teaching a graduate course next fall. So I don't know who all is considering grad school. I like grad school. I was in school in one form or another in 6 different decades. That's I think probably a record. You know, if you include like preschool, kindergarten, and you know, my master's kind of overlapped a couple of calendar decades instead of my PhD. So I really enjoyed my career. Getting a master's kind of does a couple of things, right? I mean, it really kind of finishes off your education, not finishes off, but it really takes it to a higher level, and you get to look at things a lot deeper. And that means that you're able to command a little bit more technically rich type of job, right? And maybe you get a great job offer, that's awesome, but the master's degree just kind of helps you. And in a lot of areas of electrical and computer engineering, it's almost necessary. You know, yeah, you can totally do it the non-credentialed route and do an online course and that type of thing, but that is a hard path to take. So getting that master's degree is pretty cool. It also gives you a chance to really work in more of the research side of your field. So if that's interesting to you. So I'm going to be teaching a course at night on Wednesdays. It's going to be, again, most likely remote, because I don't know where I'm going to be next fall. Maybe on a sailboat somewhere, but in the Caribbean. But I think I can figure out a way to get to internet and to be able to deliver a course once a week. So it's going to be an evening course meeting once a week, and it's going to be on unmanned autonomous vehicles. So I've worked most recently with the Army's robotic combat vehicle. It's come in 3 different variants: a light, medium, and heavy. This light is primarily for what we call ISR operations, intelligence, surveillance, and reconnaissance. And they're diesel electric hybrid. So they are designed to operate 1 to 2 kilometers ahead of the line of forces. So there's guys that are literally running, controlling his vehicle using something like a gamepad. It literally looks like that, right? It's just ruggedized a bit. And they're watching they're controlling it using a video screen and this type of thing. And they can sneak up, you know, ahead of the line of forces and go into a surveillance mode and collect all sorts of data, and you know, really keeps our soldiers safe and hopefully be able to you know, avoid deeper conflicts or to you know, have a more successful outcome. So that's just, you know, a military application. I pulled up one that the Navy's doing. We all know about aerial drones, both, you know, from the toy to the global predator type of thing. You know, I've done some work in space, and you send something to Mars, a lot of autonomy on those things now, right? Because it really needs to be. So a lot of different areas to look at in terms of unmanned autonomous vehicles. So yeah, I encourage you to take a look at that. All right, so let's get into today's lecture. And this one is, are we going to go full screen? There we go. Okay, so we're going to talk about source coding today. So source coding is kind of